differentiation regarding mixtures and compound. Okay, the differences between the mixture and a compound. Okay, if you see the mixtures, there are 5 main included topics are represented. Okay, what is the first one? It is nature. Nature. What is the nature of mixture? Just now we discussed. When 2 or more elements or compounds or both are mixed together such that they do not combine chemically. They do not combine chemically is a keyword over here. Okay. If you add 2 or 3 elements or compounds or both, they'll not at all mix chemically. Okay. Fine. That's a property also I showed you in physical change. Yeah. Here, coming into compound section, when 2 or more elements unite chemically, a compound is formed. They have to unite chemically only. Here, there is no need of chemical combination. Okay, there is no need of chemical bonds. Here, there should be a chemical bond. Okay, to form a new compound. Coming next is all about structure. What is the structure of the particular mixtures? Mixtures are generally heterogeneous, it seems. Okay, mixtures are generally, I said no, most of the mixtures are heterogeneous. And however, some mixtures can be homogeneous too. Okay, and coming here, compounds are always homogeneous. Very important. Compounds are always homogeneous. Okay, coming next is all about composition. The next characteristic is composition. Okay, in composition, in case of mixtures, their constituents can be present in any ratio. We know there is a variable composition all through the mixtures. They can be present in different proportions, in indefinite proportions, different ratios. Okay, they can be present in any ratio, and the mixtures have variable composition. This is the first characteristic we discussed. Okay, and here, in case of compounds, the constituents are present in fixed ratio by weight. We told the example, no, hydrogen and water are present in which ratio? 1:8 ratio. Very good. They're forming in which part? What part? 9 parts. Very good. Next property is, next characteristic properties. In properties section, we can easily see the constituents of a mixture retain the individual chemical and physical properties. Because there is no chemical formation going on, there is no chemical bond, so they'll have their own properties physically and chemically. Okay, and coming next, the properties of compounds are entirely different from that of properties of its constituents. We discussed now, hydrogen plus oxygen gives rise to water molecule, sodium plus chlorine, very good, gives rise to sodium chloride. Okay, and the last characteristic is all about separation of constituents. How the constituent mixtures are separated in the mixture category. The constituents of a mixture can be separated by applying physical methods. What kind of physical methods? Let's see. Solubility, filtration, evaporation, distillation, and use of some magnets. Iron fillings, magnets, yes, very good. So what about the compounds? The constituents of a compound cannot be separated by applying physical methods. They can't separate by using any physical method. It should be compulsory or chemical method. However, constituents of a compound can be separated only through chemical means, by chemical methods. It means, okay, by chemical methods. This is all about this particular one. So, let me ask you a final question before I end this particular session, children. Okay, what's the question here is? Here we go. Yeah, copy the question. Note it down. Is air a mixture or a compound? I'm talking about air. You know air? Air. Is air a mixture or a compound? Tell me the answer now. Is air a mixture or a compound? Come on. How many of you are saying it's mixture? How many of you do the answers called compound? Okay, let me give you some 3 important points for clear understanding. Then you can answer me, okay? The first point here is about mixtures and compounds, okay? Do mixture have any particular formula, children? No, right? So, I can write here, there is no definite formula. There is no definite formula for mixtures. Okay, and this particular components You know, air consists of various gases and in different places, right? The various components of gases can be separated. How that can be separated? Okay, they're present in various places, children. So, various types of gases are present in different places. Yes? They do present in different places, different areas. Okay, all through the atmosphere, right? So, the various components of gas are present in different places. You know how these particular components are separated? There is a important physical method to be separated, and that particular physical method separation is called as fractional distillation. What is that? Fractional distillation. What is that, children? Fractional distillation. These air components are separated by physical means. By what method? Fractional distillation. Okay, there is no definite formula for air, and there is no chemical method. The simple physical method is done. We can easily differentiate the air into some different components. Okay, and what is our final point here is done. Okay, so here based upon these 3 points, can you say this air is a compound anymore? After observing all these 3 points, there is no definite formula. There is various gases present in different places, and if they do, we can happily separate them with a physical method called fractional distillation. So, how many of you are ready with your answer? Yes, ma'am, air is a mixture. Okay, not mixture, ma'am. I will go with compound. I'll go with compound only. Okay, just recollect the concepts what we discussed earlier. Compound will have, definitely they'll have a particular chemical formula, and compounds can only separate through only chemical means. Okay, here if you see that it's completely different. There is no definite formula for air, which is exactly a particle, a constituent particular characteristic for a mixture, and the gas are present everywhere. Okay, we know that, and it's separated easily by a physical method. Definitely air is a, air is a mixture now. Air is completely a mixture. Air is mixture. Air is not at all a compound, air is a mixture. Let me show you some composition regarding this. Okay, so here if you see the composition, 78% of the component of air is completely of what, children? Nitrogen. Completely of nitrogen. And the 20.9% of that is oxygen. Okay, and other gases greater than 0.17% and argon, the green color one. Okay, it is 0.90% and carbon dioxide is 0.03%. And we have so many components of air, and also includes water vapor also. Okay, so all these components of air are present in different ratios, different proportions. Okay, but all this coming together in air. Yeah, so nitrogen, oxygen, other gases, and argon, carbon dioxide, all these group to form a air. So that is definitely a mixture, but not at all a compound. Very good. So coming to the last slide, that is a nature of mixtures and how they defined, and the constituent how they define, and the examples of the particular things. Okay, let's see one by one what are they. First nature of mixture is here is homogeneous. This is homogeneous, and here how they are separated, how these are mixtured by using solid mixtures. There are solid mixtures in homogeneous type. For that example is alloys. You know alloys, children? Alloys means the group of 2 or more elements. So okay, so some examples here are included: brass, fusible alloy, and bronze. You know, copper, zinc, copper tin, all these are mixtures. Yes, if you mixtures, you'll get that particular alloys. Very good. Next comes solid only, but in the case of heterogeneous. Okay, solid and solid separated. Charcoal and water. You know charcoal, what is charcoal? Charcoal is the black compound. Yeah, very good. So that is charcoal and salt. If you mix charcoal and salt, you can easily pick out charcoal and pick out sand separately by using your hand picking. Yeah, true. That is heterogeneous. If you mix both salt and salt also, we can easily separate. Also, iron and sulfur. We discussed so far iron fillings and sulfur powder. Very good. Now coming again to homogeneous. Homogeneous. Now, solid and liquid here. Children, just make sure you write here liquid, not solid. Solid and liquid mixtures. Solid and liquid mixtures here are common salt in water and iodine in alcohol. Okay, common salt in water and alcohol. Iodine in alcohol is the best example for homogeneous mixture with solid liquid mixtures. Okay. Coming next is heterogeneous now. In heterogeneous also we have solid liquid mixtures. What kind of that? Let's see. Sulfur in water, sand in water. The best examples of heterogeneous solid liquid mixtures. Okay. And the other one coming next is homogeneous liquid mixtures. Okay. Alcohol in water, petrol in kerosene oil. Okay. And after that, heterogeneous mixtures with liquid mixtures. Heterogeneous liquid mixtures. Oil in water, carbon disulfide in water. Okay. And next is homogeneous liquid mixtures. Homogeneous liquid, no, that is not liquid, that is gas liquid mixtures. Okay. There are some corrections to be done, children. Observe it carefully. Homogeneous gas liquid mixtures are examples here are sulfur dioxide gas in water and ammonia gas in water. Very good. Coming to homogeneous again gas mixtures. Air. It is not homogeneous, it's heterogeneous. Heterogeneous, okay. Heterogeneous. Gas mixtures of heterogeneous are air. Yeah, mixing of oxygen and nitrogen all through the average. I told you now. And here is hydrogen ammonia. These are some, mixtures, homogeneous mixtures regarding solid, liquid, liquid gas and gas. Okay. So this is the clear definitions of all these things, children. In this particular chapter, you learn about elements, compounds and mixtures all through that. Okay. So clearly, you have a clear description regarding matter and its classification based upon chemical composition. Okay, matter is classified into pure substance and mixtures, and further pure substances into elements, compounds, mixtures into homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures include element, compounds, heterogeneous mixtures into homogeneous mixtures. Okay, so far we have discussed about matter and the chemical composition by methods called pure substance, and second one is all about mixtures, and pure substance into elements and compounds, mixtures into homogeneous mixtures and heterogeneous mixtures. Furtherly, elements, compounds, diagrams and homogeneous and heterogeneous picturization. So by this chapter we have so far clearly learned about what are elements, what are compounds and what are mixtures. This is chapter heading, right? You remember the first chapter in the grade 6 in your class is the first chapter one is elements, compounds and mixtures, and here we go. We end this topic with this clear flow chart, that is with the chemical composition. Hope you are clear with this section, children. Hope you really thoroughly enjoyed this section, and I'm looking forward for you to answer the particular worksheet bits. Okay, after listening this whole concept, I want you to answer it by yourselves, and after that you have to check the particular video. First you have to check yourself, am I doing it clearly, correctly or not? Okay, after that you can look into the worksheet video bits. Okay, so hope you all enjoyed this particular chapter 1, introductions into elements, compounds and mixtures. Thank you so much. Ending the session.